So this is fairly straightforward for question 5. Just write the equilibrium constant. So K is equal always to the concentration of the products over the concentration of the reactants. So in this case, that's going to be H2 times KOH. But in this case, there's a coefficient of 2, so that's raised to the power of 2. And then we've got a solid and water, which is a pure liquid, so there is no denominator, and this will be what the equilibrium constant is. Okay, so in this question 6, it gives us concentrations in the reactant, and it says that it gives us the number of moles, right? But it's given in a 3.0 liters, so we convert that into molarities. So it tells us the Kc for this reaction is equal to, so the concentration 1.4 times 10 to the second, and that's going to be equal to concentration of CO2 raised to the second power over concentration of CO. And that's a 2 there. I didn't see that up there. There's a 2 in front of that. So that's raised to the second power up there as well. And then it's O2 linear in that term. So I'm plugging these in. Well, I'm not going to plug them in yet because I got to do the rearrangement. We're solving for concentration of CO. So to do that, we're going to bring CO concentration up. That's squared. And that's equal to CO2 concentration squared divided by 1.4 times 10 to the second times this O2 concentration. And then we just plug those values in. So that is 0.133, that quantity squared, over 1.4 times 10 to the 2 times O2, which is 0.033, that quantity. Now, because this is, I'm going to take the square root of both sides to get what the CO concentration is. So when I do that arithmetic, that answer turns out to be the CO concentration is equal to 0.062. Now that's moles per liter. It's in a 3-liter container. The answer is asked in moles. So I've got to multiply that by 3 to get my number of moles of my CO. And that is one of the answers that's given. Very straightforward. Question number 7 gives you the equilibrium values, the equilibrium pressures. Plug it into the Kp, the expression, and come up with this answer. And you do it just like I've shown here, and you get one of the answers that's in the selection, the 5 choices. Okay, so in question 8 here, we're given a reaction mixture and its concentrations. And the question is this at equilibrium? And it gives us a equilibrium constant. So in a situation like this, we take those given concentrations, plug them in, and calculate what's called a Q. And that is then compared with the value of K. If they're the same, they are at equilibrium. If Q is larger than K, that means the products are larger than they need to be or should be, and therefore they have to move to the left to make more reactants. If Q is less than K, that means the reactants are at higher concentration, and then it has to move towards products to reach equilibrium. In this case, when you do plug these numbers in, I calculated 113, but in fact all these are given 2 significant digits, so this value should be 110. The Q is 110, K is 110. That means they are at equilibrium with these concentrations.